Using the second derivative test, find any local extrema for the function f of x is equal to sine of x plus cosine of x on the interval from 0 to 2 pi, including both endpoints. All right, so the first step that we are going to do is we are going to determine what f prime of x is. So f prime of x is equal to the derivative of sine is cosine, so cosine of x, plus the derivative of cosine is negative sine of x. All right, and then if we simplify this, it's going to be cosine of x minus sine of x. All right, and then to find our critical values, we need to set cosine of x minus sine of x equal to 0. So 0 is equal to cosine of x minus sine of x. And now in order to solve this problem using algebra skills, we can move sine of x to the other side by adding it. So we have that sine of x is equal to the cosine of x. Now where does this occur at? Well, if you think of your unit circle, sine and cosine are both positive and equal the same value when you are at pi over 4. And then over in quadrant 2, you'll have cosine be negative, sine be positive. They are not the same. If you go into quadrant 3, they will both be negative. So therefore, at 5 pi over 4, sine of x will equal cosine of x. In quadrant 4, cosine will be positive and sine will be negative. And remember, at pi over 4 and 5 pi over 4, our coordinates are, for pi over 4, square root of 2 over 2, and square root of 2 over 2. And at 5 pi over 4, we're at the negative. Negative root 2 over 2, comma, negative root 2 over 2. So therefore, the two angles or critical points that we have here are when x is equal to pi over 4 and 5 pi over 4. So now we are going to use the second derivative test to determine how or what type of extrema we have at these values. So let's find the second derivative, f double prime. F double prime of x is going to equal the derivative of cosine is negative sine, and then we have minus the derivative of sine is cosine. And now if we evaluate f double prime at pi over 4, we will end up getting the negative sine of pi over 4, which is root 2 over 2, minus the cosine of pi over 4 is root 2 over 2. And then if we subtract these, we are going to get negative square root of 2 when it is simplified. So therefore, because it is negative, that means this is concave down. So at pi over 4, we have a local maximum. That satisfies Roman numeral number 1. Now let's evaluate f double prime of 5 pi over 4. That's going to be the negative sine of 5 pi over 4 is negative root 2 over 2, and then minus the cosine of 5 pi over 4 is again negative root 2 over 2, and then two negatives make a positive in each case, so we actually have root 2 over 2 plus root 2 over 2, which is just positive root 2. Because this is positive, that means it is concave up, and we have a local minimum. So the local minimum is occurring at 5 pi over 4. That's Roman numeral number 6. So the answer choice that has both Roman numeral 1 and 6 on it is answer choice B.